Okay. Now, ladies and gentlemen, when you look at something like a sum like this, fan favorite in the exams. Okay, sorry. There we go. Okay. Let's read through the information. Remember, we are going through the process, and some of you have unfortunately failed the process again because you didn't actually read through it properly. When Marge turned 8, her friends Emily, Clara, Corey, Lisa, Shirley, and Penny were invited to a birthday party. Marge and her friends sat in a row and played a game. In how many ways can they be seen? Okay, wait. In how many ways? They're not asking you for probabilities. They're asking you for the number of ways. So you don't have to divide it by anything. Okay. But how many friends are there with her? Marge turned 8, and how many friends are there? 1, 2, 3, 4, 5, 6, 7. Marge, 1, 2, 3, 4, 5, 6, 7. So we've got 7 friends. Now some of you are going, 7 factorial. Wait. First question, and please hear me out. Let's sift a bit of our knowledge. Are they identical or unique objects? Unique. Okay? Now some of you might go and say, Asta, but it's obvious. Yes, it's obvious. But it eliminates the whole thing of repetition, which is important to look out for when you have identical objects. Now, please, if we read the question, they sit in alphabetical order. Meaning, which one is going to go first? Corey. There isn't 7 different options. You can't go 7 factorial just because you see 7 people. Only Corey can sit first. So in the first one, there's only one option. Then it's Emily. So again, one option. Then Clara. Then Lisa. I think Marge. Penny. Shirley. So in how many different ways can that be? 1 times 1 times 1 times 1 times 1 times 1. Or 1 to the power of 7. Or just 1. Okay? I laughed when I marked our prelim scripts from the school where I'm teaching. Because some kids, the moment they see a 7, it's just like, it must be factorial, okay? Then it becomes 7 factorial times 6 factorial, and okay. Now we get to an interesting little question. Emily and Clara do not want to sit next to each other. Okay. Now when you talk about metric probabilities, I'm going to always ask you, something that helps my students is think about whether you are wanting to put things in a box or you want to put things in cement. If you want to keep things together, but they're still able to move, then we put it in a box. But if we say this person must sit first and that one must be last, we're talking about cement. Or the word must start and end, or the code must have a specific, it must be even. We talk about the last one. That's the cement. Okay? So when we're talking about things wanting to sit next to each other or not, what's the easiest way to do it? To box them in, okay? But now you've got to be careful, especially with this one. Because I'm going to box them in for now. And I'm going to say, okay, if I look at them boxed in, and I say how many ways can they not be boxed in, I've just got to subtract the answer of their boxed in from the total amount. So let's look at them being boxed in. 1, 2, 1, 2, 3, 4, 5. So in how many ways can they be boxed in? Well, let's first of all ignore the box, or not ignore it, but ignore what's happening on the inside. And saying I've got 1, 2, 3, 4, 5. I've got 6 objects that are moving. But inside the box, and again, this is the important thing about identical and non-identical. Does it matter, or not does it matter? Is it different if I say Emily and Clara, or Clara and Emily? Yes. So in other words, I've got to say 2 factorial. So, in how many ways can they sit together? Well, again, 6 factorial and in the box. Don't forget about in the box. Okay, everyone all right with that logic? So, them not sitting together. Now we've got to think about if there's no restrictions. So what is it? 7 factorial. Minus them actually sitting together. If we were talking about probability of them sitting together or not, what would I have done? Or the probability of them not sitting together? Ooh, this is a lacquer one. Okay? So what is the probability of them not sitting together? 1 minus the probability of them sitting together. Who can tell me why? Let's give a mathematical explanation and let's give an algebraic explanation. Yes, sir. I love it. It is complementary events. Our favorite word for the day, complementary. But let's think about the algebraic part of it. What is the difference between number of and probabilities? What's the difference? I divide by the total number. So in other words, sir, if I convert this to a probability, what must I do? And what's the total amount? 7 factorial, right? What is 7 factorial over 7 factorial? 1 minus this over that. Love it when plans come together. Okay? Everyone all right with the logic here? So again, and I know for a lot of you that counting principles are your Achilles heel, because the English is a problem. Okay? I do not argue there. I want you guys to quickly do that one for me. It's 10.3. It's, I think, on the next page. Quickly do that one for me. So they say, you've got 7 friends. Now, this is a very typical exam type question. They love it. It's actually very, very simple if you understand the mechanics behind it. So I've got 7 friends, 4 boys and 3 girls. First of all, are we talking about identical or non or unique? Unique. Okay. Again, because identical objects, we need to remove repetitions. So I've got 7 things. 1, 2, 3, 4, 5, 6, 7. I love to draw these things, okay? 4 boys, 3 girls. Okay? Now, in how many ways, again, the question is, in how many ways? So not probabilities. So in how many ways can the 3 girls sit next to each other? So is it a box or cement? Box. So I'm going to put a box around the 3 girls. Girl 1, girl 2, girl 3. Do they specify where the girls can sit? No, so it's moving. So in other words, if I look at the amount of objects, I'm going to have 1, 2, 3, 4. I'm going to have 5 objects that can move. Again, now I ask myself, in the box, does it matter which girl sits first? Yes. Because if the girls swap around, it's a different variation. So yes, it matters which one sits first. So in other words, this person has this, there's 3 options for their 2 options for their 1. In other words, again, times by 3 factorial. And that's your answer. Okay? Is it 720? Yeah. Okay. Now they say in the next photo, determine the what? Probability. Now you can't answer them in the number of ways. Please don't lose a mark because you forgot to do probabilities. So the second question now goes, probability that Selwyn, a boy, and Lindiwe, a girl, will not stand next to each other in the photo. Again, we are getting with this thing with not together. But now we are going probabilities. That Selwyn and Lindiwe is not together. So again, we're going to say 1 minus the probability that Selwyn and Lindiwe sit together. So we're going to repeat this exact process of number 1, just with probabilities. So I'm going to say, well, again, now I've got a box, but this box has got 2 objects in it, Selwyn and Lindiwe. 1, 2, 3, 4. Okay? I need 1 more, 5. So now this is 6 factorial, because there's 1, 2, 3, 4, 5, 6. And in the box, it matters where who sits. And if there's no restrictions, 7 factorial. Okay. Everyone all right with that logic? Easy claps. If only everything in life was as easy as mathematics. What is irrelevant? Is it identical object or is it unique? It's identical because an M, whether I put MM or MM, same thing. And the moment I've got identical objects, I put a little star in my head, just here right at the back going, be careful, be careful, be careful. It's like when I've got a square root in an equation. Like if I try to solve x with a square root in the back of my mind, I put a little star. I've got to check my answers. Where else must I really check my answers? There's another 2 places. Yes? What kind of numbers?
When like the specify name give a 5-digit number, a number, And you cannot start with 0 because that changes in the number and makes it a 4-digit number.
Okay. But let's talk about broad spectrum mathematics. When we're talking about checking answers, there's an important, the one place I'm talking about checking answers is the square roots. Where else? Where must I else always go and check my answers? Calculus, the answer to everything in life. Okay. No, that's not the answer I'm looking for. Yes, sir. Oh, when I've got fractions. Because I might have a fraction that leads me to undefined. Where else? One more place. Come on, clever cookies. What about logarithms? Logs. Why? The number and the base of a log must always be positive. So you've got to be careful with those three things. And as I say, I love to do this. I make little, important little notes in my mind and I go, when I see this, remember, I've got to do this. So when I see something, when I've got identical objects, there's a little thing that I now remember, I've got to be careful of repetitions. I've got to remove repetitions. So this is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this is a 12-letter word. And just be careful, they say correct to 4 decimal places. I've got 3 M's. I've got 3 A's. 2 M's, sorry. Okay. I've got 2 N's. So 1, 2. I've got 1, 2, 3 A's. Is there anything else that repeats? No, there isn't anything else. Okay, so that's my repetitions I've got to take out. So if we're talking in how many different ways, I'm going to say 12 factorial, 2 factorial times by 3 factorial. Okay. What does that automatically now become? What do we call that? The number of events in my sample space. So that is N of S. So if I'm talking about, that's going to become my probabilities, what I divide with. If you want to group all the vowels together, again, box or cement? Box. Okay, so now I'm going to have a box with how many letters in it? A, E, A, I, A. So 5. So now I've got a box with 5 in it. I'm just going to write them here. A, E, and I. Okay? And then I'm still going to have my M, T, H. So 1, 2, 3, 4, 5, 6, 7 there. So I've got M and M, etc. there. I'm putting the M there so I don't forget I've got a repetition. So now again, is the box standing still or moving? It's moving. So in other words, how many objects are there that can move? 8 objects and 1 repetition with 2 M's. Okay? But I must not forget about inside the box as well, because they didn't specify the order in the box. So now I've got to go inside the box, and inside the box, if I look at that as a completely new word, so I'm going to go and in the box. I've got 5 letters, of which 3 of them repeat. Okay? Let's look if I answered the question. In how many ways? Yes, I answered the question. Always make sure that I answer the question. Everyone all right with a 5 factorial over 3 factorial I put at the back there? Now we get to an interesting question, and this is now going to maybe mess with your mojo a little bit, okay, and that's all right, okay? I'm here to mess with your mojo. As someone said in the middle of the bait rage. Okay. I didn't even know that word existed, okay? Calculate the probability that the word start, end with the same letter. Now again, do I have different options? Yes, so I just times by 2, right? Some of you are like, okay? No, I don't just times by 2 because I don't know whether they are the same. I've got 2 options, so I've got to look at them separate. What is always the word between options? Or. So what must I do? Add together. So now let's look at the first options. And M and an M. And yes, bear with me. I'm going to write out all the rest. A, T, H, E, I, okay, there's an M there, still another M, I, G, I, no, which one, where am I now? G, I, okay, not another I. Why am I putting so many I's there? An A and an L. Okay. Is there something missing? Is there 3 A's? Yes, sorry, there's another A in there. Okay. Okay. There's 3 A's in there, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Sorry, what am I missing? Okay, my M must be a C. My apologies, guys. Okay, just hold on. One of them must be a C, and there's an A missing as well. Oh, that's all right. Didn't do too bad for someone that's rushing for time. Okay, so here's my cement and my cement, meaning it cannot move. So what do I do with cement? I ignore it. Let's ignore it for now. Let's just look at the middle part. In how many different ways can I move the middle? Well, there are 10 different ones there. And how many repetitions are there? There's 2 A's, 3 A's. But now you've got to be careful. Does it matter whether I swap the M and the M around? No, so that's only one option. It's not 2 different options. Be careful. Whether I write M there or M there, it doesn't matter which way I have it around. So you can't say times by 2 factorial. If it was 2 different people, it would matter. So you've always got to ask yourself, does it matter? Is it different if I swap them around? No, it's not. So it's just times by 1. So it's going to be 1 times that times that. Or, what is now different in the or part? I've got A and A here. How many M's am I having in the middle? 2. So I'm going to have 10 different objects, but only 2 of them are going to repeat. Again, does it matter if I swap the A and the A around? No. But now we've got to be careful. We've got to be careful. Is this the answer to the sum? No. Because the question is not how many ways. So I've got to divide it by whatever answer I got in A. So I have to go and divide it by the n of s. Ladies and gentlemen, thank you for being an amazing group.